Hello there. In this video we're going to continue our discussion on the division of polynomials. So in the last video we discussed how to perform division of polynomials using what we called long division. So in this case we're going to discuss an alternative to long division when the divisor is a linear binomial, and this alternative is referred to as synthetic division. And we'll work through a couple examples and sort of demonstrate how to use it and interpret it. So let's first off demonstrate how to use long division in the case that we cannot or do not know what synthetic division is. So as an example, we have x plus 3 divided into 1x squared plus 5x plus 6. So we ask ourselves, what do we have to multiply x by to get 1x squared? The answer is x, and then we multiply x by this divisor, x plus 3. That will give us x squared plus 3x, for which we follow by subtraction. So therefore, 1x squared minus 1x squared is 0, and 5 minus 3 is going to be 2, and then we bring down our 6. And then we repeat our process. What times x gives us 2x? The answer is 2. We then multiply 2 by x plus 3, giving us 2x plus 6. Subtracting gives us a remainder of 0. Therefore, our answer will be x plus 2. So in general, the only thing that we really care about, as long as we have all of our powers here, is the coefficients 1, 5, and 6. And notice that when we add up these terms, we always change the sign associated to what this number here should have been. So if this was plus, then this would be minus, and if this was minus, then this would be plus. This pretty much gives birth to a shortcut representation of how to write synthetic division. So let us assume, again, we want to use x squared plus 5x plus 6 divided by x plus 3, and we want to show that this is equal to x plus 2 using this new method. So we want to divide this into the top. So this is x plus 3, so what we're going to do is we're going to put negative 3 outside of a little box, and we're going to grab these coefficients 1, 5, and 6 and put them in the top of our box. So 1, 5, and 6. So this is the setup for synthetic division. So this is called synthetic division. So we begin by bringing the 1 down, so 1 comes down, and then we're going to multiply negative 3 and 1, that's going to give us negative 3. We're then going to add everything in this column, so 5 plus negative 3 is going to be equal to 2. And then we're going to multiply together negative 3 and 2, that is going to give us minus 6. Then we're going to add everything in this column, and that's going to give us 0. So in terms of how to interpret this, this is going to be our remainder, which is 0 in this case. And remember, this corresponds to 1x squared plus 5x plus 6. So if this is a degree 2, then the coefficients in the bottom correspond to a polynomial of degree 1. So this corresponds to 1x plus 2, or x plus 2 as our quotient, which of course is our answer. Let us work through a couple more examples to sort of illustrate how this is done. So example 2. Suppose we have x cubed minus 2x squared plus 5x minus 3, all divided by x plus 1. Alright, so what I'm going to do, since I'm dividing by x plus 1, I'm going to put a negative 1 outside of my box, and then I'm going to grab my coefficients 1, minus 2, 5, minus 3, and put them in the top row of my little box. So again, I'm going to begin by bringing 1 down, so it's going to be 1, and then I'm going to multiply 1 times negative 1, which is going to be minus 1, and then I'm going to add negative 1 and negative 2 to give us minus 3. I'm then going to multiply negative 1 times negative 3, that's going to give us 3, and then add 5 plus 3, that's going to give us 8. Then negative 1 times 8 is going to give us negative 8, and then I'm going to add, and that's going to give us negative 11. So again, this is our remainder. We started off with a degree 3, therefore these are the coefficients of my degree 2. So therefore this is the same as x squared minus 3x plus 8 minus 11 divided by our divisor, x plus 1. Alright, so let's work out another example. So let's assume we have x to the fourth minus 6x squared minus 8x plus 24. Now let's assume we want to divide this by x minus 2, the quantity squared. Now let's see what this is equal to. So that means we're going to divide x minus 2 into this 2 times. So we're going to divide it into it, get once, get a quotient polynomial, then we're going to divide x minus 2 into that again and see what happens. So we're going to focus on the first one. So since this is minus 2, I'm going to put positive 2. Now notice I'm missing some powers. I'm missing a power of 3 here, so I need to include that in my coefficients. So I'm going to have 1, 0, minus 6, minus 8, positive 24. So as usual, I'm going to bring 1 down, and I'm going to multiply 2 by 1. So 2 times 1 is 2, and 2 plus 0 is 2. 2 times 2 is 4, and 4 plus negative 6 is negative 2. 2 times negative 2 is going to be minus 4, and minus 8 plus minus 4 is minus 12. 2 times minus 12 is minus 24, and minus 24 plus 24 is going to give us 0. So therefore, this, once we divide it by x minus 2 once, gives us x cubed plus 2x squared minus 2x minus 12. So what I want to do is I want to divide this by x minus 2 in order to get what I was originally looking for. So I'm going to repeat this process, and I'm going to divide 2 into it again. So I'm going to bring my 1 down, and 2 times 1 is 2, 2 plus 2 is 4, 2 times 4 is 8, 8 plus negative 2 is 6, 2 times 6 is 12, and 12 plus negative 12 is going to give us 0. So again, this was our degree 3, therefore these are my coefficients of my degree 2, which is just x squared plus 4x plus 6. So that is what my original problem, p of x over q of x, is equal to, which is pretty nice. Let's do another example. So another example. Let's do 3x cubed minus 4x squared minus 17x plus 6. And let's see if we can factor this by guessing a few numbers. So let's try and prove that this is actually factored into x minus 3 times x plus 2 times 3x minus 1. So let's prove this by showing that each of these divide into that original expression. Alright, so I'm going to begin by grabbing my coefficients of my polynomial of interest. So 3 minus 4 minus 17 and 6. And I'm going to begin by looking at the divisors. So I'm going to be looking at 3, so that's going to go outside my box. I'm then going to look at negative 2, and then I'm going to look at the number 1/3, and then I'm going to show that once I perform this synthetic division 3 times, that I get a remainder of 0 in the end. Alright, so bringing our 3 down to start the process, 3 times 3 is 9, 9 minus 4 is 5, 5 times 3 is 15, and negative 17 plus 15 is going to be minus 2, 3 times minus 2 is minus 6, and minus 6 plus 6 is 0. So we verified that 3 divides into it evenly. Now we're going to continue the process with our next number of interest, which is going to be minus 2. So 3 comes down, so we have 3 times negative 2, which is minus 6. Minus 6 plus 5 is minus 1. Negative 2 times minus 1 is going to be 2, and 2 plus negative 2 is going to be 0. So therefore we have verified that x plus 2 is a factor by showing negative 2 synthetically divides into this expression. And now we're going to start this, or end this, with 1/3. So a fraction. So bring the 3 down. 3 times 1/3 is going to be 1, and 1 plus -1 is going to be 0. All right, so since we have all of our remainders of 0, therefore all of these things work beautifully. So, therefore, this is going to be my factored polynomial, and I have proved it using synthetic division. So, in general, this can only work, at least easily, with divisors that are linear. Or if you can break up a higher degree polynomial denominator into a bunch of linear factors, you can do it piece by piece as we've shown here. But in general, it only works for linear factors, at least easily. So if you're dividing by something that is not factorable, you may have to still use long division of polynomials. Hope you enjoyed.